In 2022, an Air Canada customer asked the airline's chatbot about bereavement fares. The AI made up a policy on the spot, promising a refund that did not exist. When the customer claimed it, the airline refused, arguing the chatbot was responsible for its own lies. A tribunal disagreed, forcing the airline to pay. This was not a random bug. It was a structural design flaw built into the very core of modern artificial intelligence. The business world had a sudden, terrifying realization. The multi-billion-dollar models they were buying did not actually know facts. They were statistical guessing machines. And when they did not know the answer, they lied with absolute confidence. To understand why this happens, we have to look at how a large language model is built. During training, a model reads billions of pages of internet text. It uses this data to adjust trillions of internal numerical connections, known as parameters. This process costs millions of dollars and takes months. But the moment training stops, the model's brain is frozen in time. It cannot learn new information, it cannot access your private files, and it does not know what happened 5 minutes ago. Many people think the solution is simple. Just retrain the model with new data or fine-tune it. But that is where everyone is wrong. Retraining a frontier model every day is financially ruinous. Even worse, fine-tuning a model does not guarantee it will remember new facts accurately. It is still just guessing the next word based on mathematical probability. If a company wants to use AI for customer service, medical analysis, or financial auditing, this frozen brain is a liability. Think of it like an open book exam. Traditional AI training is like forcing a student to memorize an entire library of books before they enter the exam room. They might remember the general concepts, but they will inevitably scramble the exact dates, numbers, and names. But what if you did not force them to memorize anything? What if, instead, you gave that student an incredibly fast, highly organized assistant? This is the shift that is changing the entire AI industry. We are moving away from trying to build all-knowing digital minds. Instead, we are giving a highly capable reasoning engine a library card and a dedicated researcher. This architecture is called Retrieval-Augmented Generation, or RAG. It decouples the AI's ability to think from its ability to store information. The RAG process is surprisingly elegant. It splits the AI's job into two distinct phases, retrieval and generation. When you ask a RAG-enabled system a question, the generative model does not search its own memory for the answer. Instead, a separate retrieval system goes out and searches an external database. It finds the exact documents, emails, or manuals that contain the answer. It then hands those specific documents to the large language model, along with your original question. The model reads the documents in real time, synthesizes the facts, and writes a natural response. The AI is no longer relying on its frozen internal memory to recall facts. It is reading the answer directly off the page you just handed it. If the information in your database changes, the AI's answers change instantly, without a single cent spent on retraining. But how does a computer search through millions of unstructured documents, like PDFs, emails, and chat logs, to find the exact paragraph you need? It does not use keyword search. It uses math. Before a document is stored in a database, it is run through an embedding model. This model translates the conceptual meaning of words into a long string of numbers, called a vector embedding. Imagine plotting every word and concept in human history on a massive, three-dimensional map. Words with similar meanings are plotted right next to each other, even if they use entirely different letters. For example, the word crimson and the word red will share nearly identical coordinates on this map. When you ask a question, the system translates your question into a coordinate on that same map. It then looks for the data points closest to your question. This is semantic search. It allows the system to find the right information even if you do not use the exact keywords. This mathematical shift has sparked a quiet war in the enterprise software market. For 40 years, the world's data was ruled by relational databases, pioneered by giants like Oracle. These systems organize data into neat rows and columns, searched using rigid code called SQL. But relational databases are terrible at understanding the messy, unstructured data that makes up 80% of a company's files, things like audio recordings, internal memos, and legal contracts. To survive the AI wave, legacy database giants are spending billions to retrofit their systems with vector capabilities, while venture-backed vector startup platforms are raising massive valuations. The prize is immense. The company that controls the vector database controls the memory of the world's corporate AI systems. Because without a vector database, an enterprise AI is practically useless. But RAG is not a magic bullet. It introduces an entirely new set of engineering challenges. First is the problem of context window limits. An AI can only read so much text at one time. If your retrieval system hands the model a 1,000-page document, the model will run out of memory, or worse, suffer from a phenomenon known as being lost in the middle, where it ignores information buried in the center of its prompt. Then there is the issue of data hygiene. If your company's database is filled with outdated PDFs, contradictory policies, and inaccurate spreadsheets, the retriever will pull those bad documents and feed them to the AI. The system will still output false information, not because it hallucinated, but because you fed it bad data. The old computer science rule still applies. Garbage in, garbage out. Despite these challenges, the shift toward retrieval-augmented generation represents a fundamental change in how we think about computer intelligence. For the last few years, we have been obsessed with the size of AI models. We assumed that the path to artificial general intelligence required building larger, more expensive brains that could memorize everything. But the future of software does not belong to a single, giant, all-knowing brain. It belongs to lean, highly efficient reasoning models that know how to search, verify, and read. By separating reasoning from memory, we are creating AI systems that are cheaper to run, easier to audit, and grounded in real-world facts. The age of the frozen, hallucinating AI is ending. The era of the digital librarian has begun.